Hey guys, back again. Gonna show you now. Our topic of today is basically minerals with special properties, and special properties are important because it helps us to identify minerals. Because certain minerals have different things about them that says, "Oh, only that mineral has that." So now, based on that identification or based on that property, I can now tell what I'm looking at. And on the screen right here, we can see that we have color, luster, streak, hardness, cleavage, fracture, yeah, I guess magnetism, acid test, radioactivity, fluorescence, all kinds of crazy stuff to help us identify what we're looking at, even smell. And actually, that's what I'm going to start off with because there's one mineral in particular that has a strange smell to it, and that would be sulfur. Sulfur looks like this. This is a sulfur based mineral. And if I was to take this and bash this up and kind of smell it, it would smell like it has a little smell to it right now. It smells like rotten eggs the more I bash it up and put it into a powder form. So yeah, that's a sulfur right there. So I can identify that based off smell, and it does smell a little bit. All right, and the more I put it into a powder form, and the more I create like a, I guess, a dust or put that smell into the air, I'm like, oh man, that smells bad. Okay, another one is called magnetite, and magnetite is an easy way to identify it. It's basically with a magnet. And here's the magnet, and here's the mineral, and this is the only mineral and I believe on the planet that is magnetic. So magnetite is easily identifiable by a magnet. And see, it looks sort of like this graphite, doesn't it? Doesn't magnetite and graphite look alike? But see, graphite is not magnetic. It is not doing anything. I don't want to drop it. However, I could take this and put it onto or get a piece of paper and scratch it, and I can actually draw with this. So I can identify what I'm looking at with that this is graphite just by taking a sheet of paper and drawing on it. And it's like if I took magnetite and did that, it's not going to do anything. It's not going to draw at all. So, yeah, I can even identify a mineral by taking a piece of paper and like that. All right, that's basically a scratch test, but it's on a piece of paper. Okay, luster. Luster is how bright something is or how it reflects light. And this right here is galena. And galena is very lustrous. It reflects light really well. And so does pyrite. Pyrite reflects light pretty well. So you can see that they're very crystalline and shiny. Well, that's because they're reflecting light. Now, pyrite is also called fool's gold. There is a test that I can do. It's called a scratch test that can let me know if this is gold or if this is fool's gold. And if this was real gold, I would take a scratch plate and I would scratch across it and it would be yellow. However, pyrite, when I take it and I scratch across it, it's black. So that is an easy way to identify a mineral based on the powder it leaves behind when I scratch it. Okay, so that's pyrite. Now, certain minerals, very few, actually only come in one color. And I have two of them right here in front of me. One is malachite. Malachite is always green, almost like kryptonite, right? But it's not. It's just malachite. Malachite is always green. Now, malachite is kind of dull in color. It doesn't reflect light really well. Instead, it absorbs it, and so you're not getting a lot of reflection off this at all. So, again, this is malachite, always green. And then there's another one called Vandenites, one of my favorite minerals. It's beautiful. Vandenite is always red, and you can see some Vandenite right there. Okay, so Vandenite's always red. So color sometimes is useful to identify minerals, but it's more rare because one mineral can be many different colors, and that's typically true. But once in a while, we do get those special ones that is always the same color. All right. This is also malachite, another example of malachite. Another test is hardness, and this is talc. Talc is one of the softest minerals on the planet, and you can even take your fingernail and scratch it, and I don't know if you can see it or not, but powder is just coming off just with my fingernail. I have one here that is close to being the strongest mineral on the planet. This is called corundum, and it's a level 9 on the Mohs hardness scale. And I can take talc here and rub it against it and see, hopefully now you can see the powder just coming off, because talc is not scratching corundum. It's that I'm taking this and putting it on corundum or rubbing it against corundum, and it's like, oh my goodness, I'm just breaking apart. So that's what's going on there. Corundum's kicking talc's tail. All right. Last two I'm going to show you is fluorescence and radioactivity. Believe it or not, I have a Geiger counter right beside me. Not Geico. And I have a mineral here. I'm turning the Geiger counter on, and I have a mineral right here beside me that is radioactive. Now, I don't know what mineral this is. I'm sorry, I'm trying to get this Geiger counter here ready. So bear with me 1 second. There we go. Now it's active. It's ready for me to measure radioactivity. And I'll put a mineral in front of it. And you see this mineral is not doing anything because it's not really radioactive. At least the Geiger counter is not picking it up. But I have one mineral here. As I bring it towards it, you hear that noise? It's picking up radioactivity off this particular mineral. Now I have not identified this mineral yet. I don't know what it is. But the Geiger counter is picking up some of the alpha and beta particles coming off this mineral. And again, like here's sulfur, and sulfur is not radioactive. It's not picking it up. So certain minerals actually are radioactive. Last one I'm going to do is fluorescence. Lots of minerals are fluorescent. And I'm going to get this mineral right here. Hopefully you guys can see it because I have lots of lights on right now. But as let me get this one actually, I'm sorry. There we go. Here's a black light, UV light. And as I put it onto the mineral, you see it starts to glow. Take it away, it's not glowing. Put it up there, and it glows. Take it away, not glowing. Put it up there, and it glows. Now that radioactive mineral that I have not been able to identify that I showed you just a second ago, that is really, really fluorescent. So I placed the black light on there. You see it's glowing now. Take it away, it's not glowing. Put it on there, and it's glowing. So the main topic here, the main goal here is to show you that certain minerals have different properties that allows us to identify them more easily. Hopefully you found this video informative. Give it a like if you thought it was great. If not, dislike it, I guess, if you want to. All right. Thank you for watching, and I hope to see you soon.